Relations and Functions, Class 12. Exercise 1.1. Second question. Check whether the relation R defined on the set 1, 2, 3, 4, 5, 6 as R equal the set of all ordered pairs AB such that B equal to A plus 1 is reflexive, symmetric or transitive. So a relation is given to us. We have to check whether this relation defined on this set is reflexive, symmetric or transitive. Solution. Given, let A equal to 1, 2, 3, 4, 5, 6. So this is a finite set. And relation R is equal to the set of all ordered pairs AB such that B is equals to A plus 1. So here the relation is given in set builder form, where they have defined a property that is B is equals to A plus 1. So how A is related to B? B is equals to A plus 1. So we will write all the ordered pairs here using this property with the help of these elements. Okay, so both A and B are the elements of A. We cannot take any other element apart from 1 to 6. So first let us take the number 1, and we know that B is equal to A plus 1. The value of B will be A plus 1. So this will be 1 plus 1, that is 2. Okay, so we got one ordered pair 1, 2. 1, 2. We'll take another element 2, and the value of B will be 2 plus 1, which is 3. So the next ordered pair is 2, 3. The next element 3. Here you will get 3 plus 1, which is 4. 3, 4. If we take 4, 4 plus 1, 5. So the next ordered pair is 4, 5. The next element 5. 5 plus 1 will be 6. So we will get 5, 6. So here if I write 6, then you will get 6 plus 1, which is 7. But this 7 does not belong to the set A, and it is not there in the set A. That's why we cannot take 6, 7. So here we have written all the elements or the ordered pairs of the relation R. Now we got the relation in rostered form. We have to check this relation is reflexive, symmetric or transitive. We know that for a relation to be reflexive, symmetric or transitive, they have their own statements which has to be satisfied. Okay, so first we will check whether R is reflexive. So let us write the condition first. So for a relation to be reflexive, if A, A belongs to the relation for all A belongs to A. So this ordered pair must be in the relation, and element whatever we take has to be from the set A. But if you observe here, is there any element which is repeated? There is no 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? So we don't find any element or ordered pair of the form 1, 1. This does not belong to R. So we'll write here 1, 1 does not belong to R. 2, 2 does not belong to R. Does not belong to R. So on. 6 does not belong to R. So clearly A, does not belong to R. You take any element. For all the element A belongs to A. So what we can conclude here, therefore R is not reflexive. This relation is not reflexive. Now let us check if R is symmetric. So the condition for R to be symmetric, if AB belongs to the relation, if you take any element, if you take any ordered pair AB that is there in this relation, then you just flip it and check, that is B comma A must also belong to the relation for all AB belonging to A. This will be taken for granted. You have to check whether this B comma A belongs to R. So let us take element here, 1 comma 2 belongs to R. Now just flip and check, but 2 comma 1, we don't find 2 comma 1 here, so therefore this does not belong to R. So even if one case it fails, then it is not symmetric. But let us just write one more. 2 comma 3 belongs to R, so we'll take one more ordered pair, we'll flip it and check, but 3 comma 2 does not belong to R. So clearly what we can say is B comma A does not belong to R. This, after we flip, we'll get B comma A, which does not belong to R for all AB belonging to A. So therefore we can conclude that R is not symmetric. Now the condition for a relation to be transitive, if AB belongs to R, BC belongs to R, then, so we have taken two ordered pairs, we will take two ordered pairs from the relation, and how it must be, the second element of the first ordered pair must be equal to the first element of the second ordered pair. So B and B must be same. So what we have to prove here is, then AC belongs to R for all the three elements A, B, C belonging to the main set A. So if we find the format, if we find the ordered pairs in this format, we have to check whether AC also belongs to R. So do we find any ordered pairs in this format? If you observe here, this is AB, BC, right? So here 1, 2 belongs to R, 2, 3 belongs to R. But do we find 1, 3 here? We don't find 1, 3 here. So what we can say, but 1, 3 does not belong to R. Right? We'll take one more because we can find another pair in this format, 2, 3 and 3, 4. So 2, 3 belongs to R, 3, 4 belongs to R, but 2, 4 does not belong to R. So clearly we can conclude that AC does not belong to R for all A, B, C belonging to A. Therefore, R is not transitive. Hence, we can conclude that the given relation R defined on the set A is neither reflexive nor symmetric nor transitive. If you want more clarity on transitive relation, you can watch the second video in the playlist of relations and functions.